Duochrome test. This test is commonly used to refine the sphere in refraction. It makes use of the chromatic aberration of the eye. Because of chromatic aberration, the shorter waves, the green, are focused in front, while the longer waves, the red, are focused behind. In the emmetropic eye, yellow comes on the retina, while the red comes on the hypermetropic side with half a diopter, and the green comes on the myopic side with 1.5 diopters. So, after doing the trial and reaching the final sphere, if you want to check that, this is the time to do the Duochrome test. So, the patient wearing the trial frame with the correction on, one eye is covered, so we do the Duochrome test in one eye at a time. And we ask the patient to read the lines, not the final one he can get to see, but we go up a line or two to ensure that he can find the differences easily. Then we can do one of two things. Either we can put a red, then a green goggle in front of the correction and ask the patient which letters can he see better, with the red or the green. The other way around, if you don't have a red and green and you have a projector chart, you can keep the eye white, then ask the patient to read the letters, which is clearer, letters in the green or letters in the red. If the patient say that letters in green side are better, then we start to add plus lenses, plus spheres. On the other hand, if the patient say that letters in the red are better, then we start to add minus spheres. We keep on like this till the patient sees equal the red and green, or till he sees the red better. So the end point, either to see equally letters in red and green, or to say that letters in red are better. So this is an example of a hypermetropic eye. If you put +1, so everything will be focused forward. Still here, the green is better than the red. Adding more, focus will move forward. Green is in focus, red is a diffuse circle, so the green is better. Adding more power. Now both are equal. Adding more power. Now the red is in focus, so the red is better, while the green, when it reaches here, it will be a large circle, so the red will be better than the green. In case of myopia, if we put a minus lens, everything will go back toward the retina. More. Now the red is better, the green is blurred. So, regardless the patient is myope or hypermetrope, we add lenses that will make the patient see red better. This is our goal. If you compare these bands with the emmetropia, this is the emmetropic eye. As you can see here, we forced the rays, in case of hypermetropia, to be a little bit forward. So this is an overcorrection. And in case of myopia, we are forcing rays back, but we didn't reach to this state. We stopped short here, so we are making here undercorrection. So this is always the goal, to make overcorrection when you are correcting hypermetropes and undercorrection when we are correcting myopes. Why is that? If we make an overcorrection with the hypermetropia, the patient needs to do less accommodation compared to than if we make the exact correction. This is the exact correction, but we are doing an addition more, so the patient does not need to do more accommodation. He will do less accommodation than should be. See this example? With +3, this is the exact correction. With +4, everything is forward, and he will say the red is better. This is overcorrection. Patient will be comfortable that way because he's doing less accommodation all the time. On the other hand, in case of myopia, we are doing undercorrection compared to the exact correction. So the patient again will give him some rest to the accommodation. See this example, this is a correction, undercorrection, and this is overcorrection. We correct the patient more so that all the rays went back, that he can see the green better than the red. This patient is on the hypermetropic side, so he's doing more and more accommodation all the time, and this will force him into stress or eye strain quicker. So the exact rule in case of hypermetropia, we go for overcorrection, and in case of myopia, we go for undercorrection. Thank you.